Okay. So the topic, understanding rational exponents and radicals. HMH textbook lesson 14.1. If you have the textbook, you can read through the lesson. Okay, that'll always help you understand it in more in depth. All the lessons are online by going to the website for HMH, and you can access all of the textbook there without even having the physical textbook. Your essential question, how are radicals and rational exponents related? Learning goals. 1, I can evaluate expressions with rational exponents and radicals. 2, I can rewrite expressions using rational exponents and radicals. So this first slide here is a review slide, which means these are things you have learned how to do in the past. And so I want you to remember how to do them. All right, so for the first two, write each expression as a multiplication of factors, then find its value. So you can use the text tool, pick one of these colors. Okay, 13 squared, that means 13 times what? Is it times 13 or is it times 2? And then figure it out and write what it equals. Then repeat this same thing for number 2. It's 13, okay? And you have a power. 13 is the base, 2 is the exponent. The exponent tells you how many copies of the base you multiply together, right? But then you want to figure out what that is. And you can use a calculator, all right? You can absolutely use a calculator. You can use a Google calculator, like the app or something, okay? For the next 2 problems, evaluate each expression for the given values of the variables. P to the 3rd power minus 2 for P equals 3. Okay, well, we're first going to replace the P with the number, and then we're raising it to the 3rd power. It's a little hard to write, but I could just write out what that means. It means 3 times 3 times 3, right? And then we would be subtracting 2, right? And evaluating that. What does that equal? So you have to remember, do you multiply? Do you take care of exponents first? Do you subtract first? Do you add first? Don't forget about PEMDAS. So PEMDAS order. We have parentheses. We have exponents. We have multiplication and division. And then addition and subtraction. They always have to go in that order. And I'm going to make this so it's like that. All right. So when you, whoa, too big right here. Okay. So first you look for parentheses. Second, you look for exponents. Third, you do any multiplication or division going from left to right. And then finally, you do any addition or subtraction going from left to right. So I want you to finish 1, finish 5, try 2, try 6. And I'm going to give you guys some time to work on this. Maybe 2 minutes. Sorry, we've been on it a little while. Okay, 2 minutes to go ahead and do this. And I can see I already have 15 of you responding. Fantastic. Whoops, that's not what I wanted to do. There we go. That's better. Okay, so you have some time. I can see how many of you started. 16 of you started. Okay. So I got 23 out of 29 of you to respond. I went through and I was checking GoGuardian. If you have Pear Deck open, if you didn't, I sent you a command to open a tab for it. All right, so you just have to log in and start doing it. But yeah, we're up to, that's perfect. Look at that. I'm so proud of you guys. 32 in the meet. 2 of those people are me, and there's 30 people in the Pear Deck. Yay. So you must have hit login with Google. And 23 of you have responded so far. So let's see what you came up with this. So if we finish number 1 right here, and okay, show some responses. 13 times 13, what is 13 squared? 169, good. Yeah, that's what you want to have there. 169. And if I look over here for number 2 then, number 2. So this person wrote 5 times 5 times 5, but there's only 3 5s and it's the wrong sign of the 5. Oh, this person got it. This was great. So look at this one. Whoa, where'd it go? Okay. -5 times -5 times -5 times -5. Whenever you multiply a negative with a negative, you get a positive. A negative with a negative, you get a positive, and then a positive times positive is positive 625. The answer to this would be different if the parentheses weren't here in the problem, okay? But they are there, so it means we have 4 copies of -5. Awesome, 625. And then for number 5, so if we evaluate that, doing the exponent first, 3 times 3 times 3, that's 27 minus 2, and that is 25. They also got this one correct. Nice job. And for number 6, they jumped ahead to the answer. I want to see if someone wrote it out a little bit more. 5 times -3 plus 16. Yes. Okay, this is kind of showing a little bit more of the steps, which is good. And then you can go from this step to what they had up here, -15 plus 16, and then get +1 that way. So the correct answer is +1 for number 6. Okay. All right. So I'll hide those. We'll come over here. You can always go back through the Pear Deck and update your slides. All right, but we're going to keep moving forward. You can do that once I put you on student paste. But here we go, new vocab. All right, so we're talking about radical expressions. And these are expressions that contain the radical symbol. It's so radical. It's like the V in the Vans logo. Looks really similar, right? And that's a radical symbol. It's a radical expression when your expression contains the radical symbol, that thing, okay? And then if we look at the words index and radicand, those are the pieces of a radical symbol. The radicand is the number underneath the symbol, and the index is the tiny number outside of the symbol that tells you how many copies you need of a factor to pull that factor out of the radical symbol. And rational exponent. When we talk about rational, remember, numbers can be rational or irrational. That's something you learned in 8th grade last year, hopefully. It was covered before we went on quarantine break. Rational numbers versus irrational numbers. A rational number can be written in the form of a fraction. Irrational numbers cannot. Irrational numbers are things like pi and the square root of 8 and phi. Okay, so rational exponents can be written as a fraction. All right, and that's what we're looking at here. So exponents in the form of a fraction. So this is kind of review this little picture here. 2 to the 3rd power is how you can read that, or 2 cubed. 2 is your base. 3 is the exponent. The exponent tells you how many copies of the base. Now, this is kind of related to the parts of a radical. So this is kind of like what we're looking at now. You have the radical symbol. This thing, this black symbol here, looks like the V in Vans. And the number underneath the symbol is the radicand. The number that is outside on top of this little tiny piece here, it's a little number. This is the index. And all together, this is a radical expression or radical. All right, so you may have seen this little 3 here before. This means for this problem, this is a cube root. Okay, it's a 3rd power, a 3rd root. I'm looking for a 3rd power to pull out a 3rd root. You know, sometimes you would see a 2 here, or you would see nothing here, and that's called a square root. We can have any number here. We're just going to be looking at things like 2, 3, 4, 5, that kind of stuff. So since we're talking about, rational exponents, and we think about rational numbers, they're numbers that can be written as a fraction, right? 0, special case. Negatives, special case, special rules. So these are some exponent rules that were taught in 8th grade, and you may or may not have got to see them. Again, depending on if you're in class when they were taught for, you know, the time we were in class last school year. So we'll learn them right now in case you didn't. And any non-zero number raised to the power of 0 is 1. So right here, this example, 3 to the 0 power is 1. 2 4/10 to the 0 power is 1. In general, x to the 0 power is 1. Whatever you raise to the 0 power, it always equals 1. It's defined to be so. It's a rule. Now, this only works when x is not 0. So there's an exception to the rule. This doesn't work if you have 0 to the 0 power. This we can't do in math. This we say is undefined. It's like when you try to divide by 0, it's undefined. And 0 to the 0 power is undefined. Other special case is when you have a negative rational exponent. And so any non-zero number raised to a negative power is equal to 1 divided by the same number raised to the opposite positive power. Here's an example of what that looks like. 3 is my base. -2 is my exponent. -2 is a negative rational exponent. So I can rewrite this to get rid of the negative by basically taking the reciprocal of the whole thing, 1 over 3 to the 2nd power, and changing the sign from a negative to a positive. So if I move where it's at in a fraction, it changes its sign. If I move it up top, it changes its sign. If I move it below, it changes its sign. So as it moves from numerator to denominator, the sign of the exponent changes. And this is the general rule for that. So x, as long as x isn't 0, raised to a negative number, where that number is an integer, okay, equals 1 over x to that positive number. These are just 2 rules that are in the list of many rules that we have for working with exponents. Okay. And so we're going to do this slide together. Right here. This is our main idea of the slide. The nth root of a, that's how you read that. The nth root of a equals a to the 1 over n power. And so this goes back and forth. So if we have something like for this first example, a 64 1/3, we're going to find the root and simplify the expression. So 64 1/3, we're going to first convert to a radical by using this main idea right here, this rule. Okay, A and 64 represent the same number. N and 3 represent the same number. So 64 becomes the radicand, 3 becomes the index. Okay, 3 was the denominator in the exponent, it became the index. 64 was the base, it became the radicand. So I'm just rewriting it using this rule. That's first, just to put it into a root, okay, because we're working with roots. Then we want to rewrite the radicand as a power. 64 as a power, let me go to my other slide where I can write on it. Okay, so when you think about a number like, whoa, yeah, no, I have to make that much smaller. Okay, 64. Let's think about the number 64. 64 is made up of 8 times what? 8. And this is made up of 2 times 4. This is made up of 2 times 4, right? So 2 times 4 times 2 times 4, well, that's the same thing as 4 times 4 times 4. That's equal to 64. Okay, so I can rewrite 64 as a power of 3 to match my index. Because the index here was 3, I want to rewrite it so it has the same power. And now this is like inverse operations. They cancel each other out. I could pull 1 4 out because there's 3 copies of it inside. I have to have 3 copies, 4 times 4 times 4, to pull 1 copy out. And that's where this comes from. Okay, we're going to do this next one together. So this is a good time for you to have your meat on your window and also have your Pear Deck on your window, like side-by-side windows. You know, remember how to do that? You just resize them and you just move stuff around so that you're seeing 2 things at the same time. Right? That's what I suggest you do, because we're going to do this one together right now. And this thing got kind of funky. Oh, there we go. Okay, I have 8 of you already on this slide copying along with me. So you should be copying along with me because we're going to fill this in together. Right? So we're going to do B now. 81 1/4 plus 9 1/2. So we want to do the first step, which is to convert to radicals. 81 1/4. We're going to use this rule. Okay. The base becomes the radicand, and the denominator becomes the index. Okay, so write what 2 numbers you think go right here. I'm going to see what you guys are doing. $81. Good, that's your radicand. You can type them or try to write them. 81 goes here. Okay, what's going to be the index? What do I write where the index goes? Yes, this person has it. A 4 goes here. Okay, so this rule works anytime our numerator is a 1. This is all you got to do. Today we're just going to look at powers where the exponent's a fraction and the numerator is 1. Okay, I will turn this to like student pace mode, and you could go forward and look at what will happen when the numerator is not 1, but we're going to save that for Friday. So today, all of our problems we work with, the numerator will be 1. All right, so you don't have to do anything special with it. What about the second radical. What's this going to turn into, right? So we have, use some different colors here. We have our base, right? And we have our denominator. Okay, I'll unmute. Is that what you're going to say? Thank you, Isaac. Appreciate that. So I had to mute myself and turn off my camera a second and go see why my dog was whimpering. They're like children, but not. Okay, so anyhow, we could put the 2 right here, just like this person did. Okay, so that looks good. Now, do you have to put this 2 here? I mentioned it. I don't know if you remember what I said. Is it necessary? Because I mean, they didn't give us the little, you know, that little box like they did for the 4. That wasn't there. And that's because you don't have to put a 2 there. So this is the thing about a square root. Okay, if you don't see it, it's an invisible 2. So if you have a 2 there, or if you have nothing there, it's implied it's a 2. It's kind of like when you have, say I had this expression, 3 plus x, right? There's invisible stuff that I just don't see. I could always write 3 over 1 and it doesn't change it. I could always write a 1 in front of the x and it doesn't change it. Okay, it's kind of like that. There's stuff you can do that you don't see. And there's also invisible exponents, right? There's invisible exponents of 1 that you could put in because it doesn't change the value of stuff. So it's kind of like this with the square root symbol. If you see nothing, it's implied it's a 2. But if you see another number, then you have to use the number you see. All right. So now that we've done that, we're going to rewrite the radicands as powers, which means I'm going to rewrite 81 as a power with exponent 4. So kind of running out of room here, but look, 81, what is that equal to? Okay, what number would I put here and then raise it to the 4th power? What would that be equal to? Think about, you know, how I broke up 64. You do the same thing with 81. Come over here, 81. That's the same as 9 times 9. 9 is the same as 3 times 3, right? So what would the number be that I could rewrite 81 as a power where the exponent is 4? Let's see what you guys are putting. What number would go there? So I have 18 of you so far writing. Everybody should be writing on this slide because we're doing this one together. So you should be filling in yours as I'm filling in mine. We should not be at 18 participating people so far. I got you guys to join the Pear Deck. That's great, but you need to actually go to it and start writing on it. All right. So see how there's 1, 2, 3, 4 copies of 3? That's because 81 is the same as 3 to the 4th power. So we can put 3 to the 4th power. How can I change 9 so that it's something squared? What number can I put here now? We're up to 20 of you that have now started writing over here, which is good. need to all be writing over here. How can I rewrite 9 as something squared? So I'm looking for someone that has the right answer. What goes in this box? What times what equals 9, so that we're multiplying the same number by itself? So what about 3? 3 squared, 3 times 3 is 9, okay? The reason we did this is so that we can simplify these roots. So if we apply the definition of the nth root, which means the 4th root of 3 to the 4th power, the 4th root of something to the 4th power, these cancel each other out, and we're just left with 3. The second power, a second root of a number to the second power, the square root and the squared cancel each other out, and we're just left with 3. So now we're just down to the last step where we got to simplify. PEMDAS order. We took care of exponents, and now we have addition left. So what is the last piece here? The last box. There we go. This person got it. 6. Yeah. 6. I'm going to put a 6 in this box. Let's just switch colors. All right. 6. We did it. So this plus that is equal to 6, because we just showed how to do that. So this is the new thing we're learning about. You know, time-wise here, we have 2 minutes. So let's see. What I'm going to do is I'm going to move you guys forward to the last slide. I'm going to give you 2 minutes to work on the last slide. Okay. And then I'll give you the correct answers. And then I'll be out of the lesson. And then you can, by looking at our week at a glance, you have 2 things. So you could start working on the Delta Math assignment. Although we're only covering how to do half of the problem so far, but maybe you want to move forward in the Pear Deck and try to figure it out on your own. But this assignment for Delta Math number 9 will not be due until Friday at the end of the day. So you can start this one, see how it goes. Or look and see, have you done number 3? Have you done number 5? Have you done number 6? Have you done number 7, Aries? If not, or if you did and you didn't earn 67%, work on getting that done so you have the opportunity to retake a test and you're not failing. Not everyone's failing, but too many of you are. Okay. So, got another minute to try this, and then I will put up the correct answers to that right at 45, and then I'll turn you guys loose. Okay, 45. Here we go. So 8 to the 1/3 power is the same as the cube root of 8. Cube root of 8 is the same as the cube root of 2 to the 3rd power. Those cancel each other out. You're left with 2. Right? And over here, 16.5 plus 27 1/3. Well, rewrite these as roots. Rewrite the radicands as powers that match the index. Okay? And then simplify. 4 plus 3, you can get 7.